We should have let that go for a lot longer. It's a great track. All right. Thanks. Thanks for the intro. I'm Ben Schwarz. I'm from Melbourne, Australia. It's my first time here in Sweden, so thank you so much for having me. You're all a big crowd, a good-looking bunch of people. Alrighty. My talk today, no speaker notes, that's fine. My talk today is centered around performance. And don't worry, it's not a product pitch for the next 30 minutes or anything like that. But this is what I do. I build some software called Calibre. It's a performance monitoring tool. So all of the work that I do every day is about researching performance on the web, figuring out how browsers work, driving browsers, and trying to really improve performance for everybody. So I've learned a tremendous amount over the last couple of years. Yeah, I guess the premise of today is that I'm going to take you through some stuff that maybe isn't, sort of first of mind for you. When we talk about performance these days, we usually hear some stats about how much money Amazon makes if they make something faster. We hit reload a couple of times and then we call it done. But there is a lot more going on in the browser. We send some HTML down, we send some scripts, maybe we have some JPEGs, some other stuff going on in there, and we just kind of throw it at the browser and kind of hope for the best, right? We have some fonts in there, other bits and pieces. So performance usually happens here. Usually you've got this project timeline and everyone's working really hard the whole way along, and then somebody comes and says to you, oh, hey, is the site fast? And, well, the answer is, well, no, but let's just do our best, right? And where performance should happen is along the whole process, right? Like, you can't just wait until the end and go, oh, I guess we've got no time left, let's just try and make it really fast now. That ends up with a bad user experience. So today, I'm going to take you through the state of global connectivity, and we're going to look at how people actually access the internet. I've noticed here there's super fast internet, and it's widely available, but that's not true of everybody. On the planet today, 7.4 billion people. But of those 7.4 billion people, less than half of us have access to the internet at all. Which means 53% of us, almost 54, have nothing. No connectivity. Not a phone, nothing. If you were to look where the internet is growing and like where it's growing quickly, the first place, if you start actually doing a little bit of research, is you'll end up looking at stats of India. In just last year, 108 million people got access to the internet for the first time. Now, that is, I checked, that's almost 11 times the entire population of Sweden. And also for my country, Australia, that's like 5 or 6 times the entire population. And that's every year. And at the rate that it's going to increase for 2017, it's rumored to be about 140 million people. This is year-on-year growth like we've never ever seen before. And of the 1.2 billion population in India, 65% of them have no access to the internet at all. In case you're guessing, that's 860 million people. That's China again. If you go and spend some time looking at the minimum wages of these 4 countries, and then you look for a mobile data plan, prepaid mobile data plan, prepaid's usually cheaper. For you to have just 500 megs of data, you'd need to work in Brazil 13 hours. Here in Sweden, it's actually less than 1 hour. So that's 1 hour for 8 songs on Spotify, 6 minutes of YouTube, and less than an hour playing online games. Or the more fun way that I like to think about it is if you go to The Verge and empty a cache and then hit the empty cache button on your Chrome DevTools and then hit reload 38 times, you'll use that data. This is quite an addiction to data that we're seeing on sites today. They're bigger and bigger, and sure, we're doing more interesting stuff, but at what cost? Even though data varies in prices and availabilities in different locations, you'll see that the speed is very different as well. India, right down here with 6.3 mbits per second. Sweden's not doing too bad, although Denmark are beating you all, so don't know about that. But in essence, the internet here is very, very good, and it's very, very cheap relative to what you're paid here. If you go and look at the global average connection speed, so this is a wired connection. Any guesses as to what the global average would be? Well, it's just 7.2. This is actually up from 6.8 last year. So in many, many cases, having a 4G connection is actually a lot faster than a wired connection. However, of all of the connections that we're seeing around the world, only 60% of them are actually 2G. And that doesn't just mean 2G speed, that means actual 2G. That's not like you're in a tunnel and it's not working, it's just 2G. So even if you have LTE, we know ourselves we can't assume it to be fast because there's situational things like tunnels and conferences when Feroz comes here and asks you all to join his P2P network and brings the whole thing down while I'm practicing my slides. That works really, really well. When you look at handsets, handsets are the majority here, yet for some reason, even though we heard about responsive design a number of years ago, we're still building sites. I mean, how many designers at companies are actually going and building sites for a desktop first? And they go, oh yeah, we'll do the mobile views quite soon, I'm sure. And then they never arrive. We're not thinking about data in the way that we should be. I went and did a little bit of research to go and see what phones are being sold around the world, because surely everyone just buys the same thing that I do, right? Well, the answer is no, not true. I was quite shocked to see that there were a number of phones that or a number of manufacturers that I had never heard of. By the way, the little face over here is, it's so fragmented that I couldn't fit it on my slide, so this little guy here. And those aren't just like a couple of phones, right? We're talking hundreds of millions of phones sold every year made by companies that I've never heard of. Has anyone heard of any of these? Some of you, yeah. So I got to wondering, is there a device, there's such a fragmented market that we don't understand. Is there a single device that kind of best gives us an average phone? And the answer is yes, kind of. This is a Motorola G4, Moto G4. If you were to, kind of look at an average phone, it's actually way ahead of an average phone. If you were to buy one of these today, I'm not sure how much they are in local currency, but in euros, they're about 180 euros. They're a very, very capable phone. They've got plenty of space on them, and they've got plenty of RAM. Actually, more RAM that's being put into the cheaper phones that are being bought in other locations in the world, so it's still not an average phone. But it does have one quality that's very interesting, and that's the quad-core CPU. This quad-core CPU is one that's used on 3 billion Android devices already in population. So if you were to buy one of these, they would give you, in the next year, a really good device to be able to use for testing. Of course, if you can't afford or don't want to go and have a second phone or don't have an office phone, you can go and do this in Chrome. You go to the Performance tab and you pull down to slow down the CPU to at least 5 times. When I was able to do that on my reasonably new MacBook and then benchmark something on a Moto G4 and my MacBook, they performed around the same. But what's very true is that there's 2 versions of the internet. There's the one that we use every day as developers in our offices and at our homes and maybe at our universities. And then there's the one that we don't. While I'm traveling to the other side of the world, I'm kind of over in this area over here, where sometimes the Wi-Fi on my flight over the ocean is better than what is in my apartment. It's very possible to have a different situational connection. Conference Wi-Fi here has been great. Congratulations to everyone who worked on that. They've done a great job. Li-Fi, however, happened when Frost was doing his little thing. It's when it says that you have Wi-Fi, but nothing happens. But one thing is true. We got to stop optimizing for $3,000 computers with really fast connections. We've got to start feeling what people are feeling. We've got to train ourselves how to diagnose things and understand them and then fix them. Because after all, that's kind of our job. Performance is not just something that's fun. Performance is the user experience. And as an industry, we need to stop putting our own sort of desires in ahead of the other people that we say that we're building for. I added this during Paul's talk. You can hate AMP all that you like, but you know what? It's creating a faster site than most people are building. So you can hate it all you like, but let's try and start looking at performance and actually making some positive improvements. I'm going to talk to you about a concept called the critical request. A critical request is a request that the browser needs to make that represents something that's in the user's viewport. It's essential for them to see something. It's that kind of fold that we were talking about. So what makes a critical request critical is that different assets are actually given different priorities as they download. So your HTML is actually given the highest priority, and then your CSS is given also highest. Web fonts are also highest. Everything's high. If everything's high priority, nothing is, right? Interestingly, images, though, are given a low priority at first, and if they're rendered in the top of the viewport, they're actually upgraded to medium. So if you imagine, your Chrome DevTools with a request, it will place files in that queue, and if they're at a high priority, they'll get bumped ahead of each other, right? And up until now, we haven't had any control over this. One thing that's really quite interesting, I think, is web fonts. And we've been doing some really poor, pathetic stuff with web fonts for a little while. But one thing here is true. We're delivering these fonts because we want them for our brands. It's really important to us, right? But unfortunately, the web that we have today is actually not as good as the web that we had when the web started. We have these fonts that we say that are important, that we're saying that we're caring about the customers. But I got to tell you one thing. Just render the text. So stepping into a CNN, and I'm sorry that all news globally is just completely crap at the moment. I can't do anything about that. Looking at the CNN site here, we can do a quick visual audit to say like what we need for this particular context, which is on a mobile. We need the logo, we need the font. Actually, we need 3 sizes of fonts, and we need 3 font faces, and we need the lead image here. Interestingly, with CNN, they're actually, I don't know if you want to shout it out, that's fine. Anyone pick the font that they're using here? Looks like Helvetica, Comic Sans. Yeah, that's nice. It's actually a font called CNN. And I went and did a little bit of a test, and it was indistinguishably different to Helvetica. It was actually just a little bit thicker. But they were still serving 3 web fonts on this single page. And that came at a real cost. The fold is the user's viewport. And yes, it is real. I did a little audit. You can go and do this yourself in your Chrome DevTools. You slow down your CPU at the top, you slow down your network speed, and then you can go and see where the browser is painting by mousing over there. It doesn't matter if you can't see it, but the browser didn't paint until the 10th second. It took 10 seconds to send anything with just kind of an average 3G connection. And all the panning around there I'm looking to see where the fonts were. I actually couldn't find them. I didn't know when they loaded. So to understand what kind of maybe happened there, you have to kind of understand how fonts work. Firstly, for a font to be even requested to be loaded, there needs to be a style sheet. It needs to target an element. that element needs to say, hey, I need the CNN font. Then there needs to be an @font_face declaration to say, oh, here is the CNN font. And nothing will be requested until that point in time. So if you're doing a single page app and not rendering any text, you're actually maybe delaying the text from rendering at all until the JavaScript is loaded, parsed, executed, CSS, and then the font will be requested. That can really, really slow down that critical first paint. So I went and did another audit. You can see requests filling in here over at the right. And I scrolled down and around. I couldn't find the font until still nothing is rendered, and then bang, found it. The fonts were 53 requests deep, and it was critical to that page being viewed. But there is actually something that we can do that's really, really super powerful, and it's really new as well. Link-rel preload allows you to specify assets that you're telling the browser, you don't know this yet, but please go and download it. It'll get that asset and it'll move it to a high priority. So you can see here on the Calibre site, which is my app, I added the preload tag to 2 fonts. They were both WAF fonts. And you'll see that the first request was the HTML, and then the next 2 requests were the web fonts before the CSS loaded. So what happens is the browser parses the CSS, finds an element that uses a font, and the font's already loaded, so it just appears straight away. This can really improve your render speed quite dramatically. So the impact of that, 68% of sites on the web use web fonts. In the test that I've done, you can save at least 3 to 5 seconds. So if you were to remember anything from my talk today, it'd be have a play around with preload, add your fonts, and get them down to the customer as soon as you can. If I was to give you a little performance checklist that you maybe want to remember and take home, it's try out preload. It's really great. There's lots of testing you can do there. There's a new thing called font display, which has a couple of options. One option is called optional, and it will tell the browser, hey, this font is actually completely optional. If you can't load it within a few hundred milliseconds, just give up on this web font. That's pretty cool. I quite like swap, which renders the fallback font. So in the case of CNN, it would render the Helvetica until the CNN font loaded, and then it would replace it. Right? So you don't get that flash of text where something's not there and then it is there and it resizes. You just have Helvetica. And another great thing that you can do is use fallbacks. So if you've spaced your Helvetica carefully using maybe a class, maybe using a font face observer API to add a class to say we're using Helvetica at the moment, you could even your line heights to make so that the page doesn't jump around and disturb the user as the page is loading. And again, you should use WAF and WAF2 where possible, because they're compressed file formats. Interestingly too, if you're going to preload the fonts, you don't need to preload the older fonts like the EOTs, etc. Just preload the WAF, because anything that has support for preload also has support for WAF. So looking beyond delivery, when we do performance work normally, we talk about how big a file is and how long it takes the device to download it and how much bandwidth there is and all of that stuff. One thing that we're really, really forgetting is this middle section called parse. And what we're doing is we're ignoring the fact that we're blocking the main thread. This is really super important. In the case of Chrome, this is kind of how V8 works. This is an approximation. This graphic came to me from Adi Osmani. And it explains how Chrome works now. This is actually a recent change. They take your JS and they parse it, and then they turn it into an AST, and then they optimize it a little bit, generate it into bytecode, and then it eventually runs on your architecture. The average size of scripts on sites today is 453 kilobytes. But it's actually not 453 kilobytes. So if you're focusing on delivery, yeah, sure, it's 453 kilobytes. But the browser then has to go and uncompress that and then turn this giant wad of JavaScript into something that actually runs. Now that's a big deal on a mobile device that doesn't have the same power as your $3,000 MacBook. Oops. So if you get 1 megabyte of JavaScript and look at the parse and compile time over this huge array of devices, at the top there we've got a MacBook Pro running Safari 10. Each browser obviously has a different JavaScript engine and they perform in different ways. This is just the parse and compile. So this is just that process of making the JavaScript ready to execute. If you look, where's that Moto G4? Right there in the middle over here, Chrome 55. So 1 megabyte of JavaScript is like 1.6 seconds. That same JavaScript executes in just a few milliseconds on a fast computer. The Nordic side looks fantastic. Loads reasonably quickly, and it's not a bad side at all. And I'm not going to pick on it too much, but I'm going to just show you what that difference can be in terms of script. The script on the site was a little above the average, 560 kilobytes, which decompressed was 2 megs. So if I went and did a little bit of measurement on that parse and compile process on my desktop and then a Moto G4, it was 2 seconds, actually 3.5. I missed my note there. But you can see on the desktop, it still took 800 milliseconds. So it's actually quite a bit of time. Now what that means on a mobile device, I'm sure you've all seen it, is you're on the couch and you're navigating around, and the site loads and it looks like it's ready, right? And then you scroll and you're moving your finger, but nothing's happening. That's parse and compile in action. This wad of JavaScript is just killing your phone, and it takes a little bit of time for the phone to catch up, and then suddenly everything is fine, and then it scrolls all the way to the bottom of the page, and then you've clicked on a link for an ad, and then you don't know where you are anymore. That's at least my experience. A little while ago, I did this experiment. Now, this is it's available here. I wrote an article about it. It's called Your Site Without JavaScript. And I don't think it's fair to say, oh, yeah, well, nobody turns off JavaScript, so let's not do it. This is a process of benchmarking your site. How fast could it be? How fast can your site be at its best? So on one side here, we've got The Guardian without JavaScript. And on the other side, we've got it with JavaScript. Now, I'll fill in the blanks here, but the example is the version without JavaScript loads, fully renders in less than 5 seconds on a 3G connection on a phone. That's extremely good. The other version, well, it loads some weather, another thing, the fonts pop in, they pop out, they disappear. The image doesn't show until, let's see, 9 seconds. And it's not the fact that, I mean, this JavaScript is doing a lot more. But to me as a user, it's not really more useful. I'm just trying to see what the news is, right? The problem is that we're delaying the paint because we're not prioritizing the resources properly. We're adding the script and it's delaying it because of the way that priorities work. But also there's a cost to that data, remember? This site was actually weighed in at half the amount when I turned JavaScript off. And I know that there was some extra functionality there, but I think that's a huge cost that we're enforcing on our users before they've even seen anything. They can't even decide if they like the site to leave it. I wrote this a little while ago. I think it's quite true, actually. I know I was totally trolling, but yeah, it's really cheap if you just delete all of your JavaScript and your site's really fast and it's really great. Or you can just keep writing all this amazing stuff and you've got TypeScript and that's really cool and you're high-fiving and playing ping pong. But ultimately, this is expensive work to do. And I mean, I am joking, but we can do a little better. One thing that you can do to do a little better is you can just use this brand new thing, or reasonably new thing in Webpack. How many people are using Webpack, by the way? Wow, all right. It is using the ES6 import, and then there's this Webpack magic comment thing, and you're basically telling Webpack that, hey, if you're going to split my bundle, this is a point where you can do so, and it'll split this import into a different chunk. And then, if you're using something like React Router, this will also return a promise, by the way. So if you're using something like React Router, you could then say like, oh, don't load this thing until, the user gets to this route. What that means is that you're delivering a smaller bundle, which has less parse and compile time, and you're just breaking it up. In the end, you're still delivering just as much script, but you're offsetting that weight that the user will have. Another thing you can do is use the Common Chunks plugin, which will get your dependencies like your reactor or your whatever it is, and we'll separate it out into a different file, which you can load and then cache forever. It doesn't help with parse and compile, but it does help with the fact that the device has already downloaded it, so it doesn't have the delay of the download, then the parse. So as to give you a little checklist for JS, I'd say definitely try out code splitting, serve only what people need, test using a real device, get that Moto G4, slow down your browser, do all of those things, and monitor parse and compile time, because it's one of those hidden costs that people kind of aren't seeing. So if you're going to try and improve your performance in general, there's a couple of things that you need to do. Firstly, we need to realize that the metrics that we're using now don't tell us anything about user experience. And the metrics that I'm talking about are those onloads, those on-DOM content loaded. They're points in time in a timeline, sure, but they're not explaining what's happening to a customer. Good metrics are ones that explain what happens. First paint. First paint is when the browser goes from that white screen to anything. Something's happening. First meaningful paint. First meaningful paint is the point in time when the user sees text. Visually complete is when the browser is visually complete. And time to interactive is a little bit more involved. Everything is rendered, and there's been a point in time when there's no parse and compile. So, if you're going to scroll, the phone is actually, or the device is actually going to react. Or maybe if they tap on a button, right? So time to interactive is a point in time where if somebody interacted, it would react. So to recap on those, first paint is when you see something. First contentful paint is when you can see some text. And then finally, first meaningful paint and visually complete. These are human-centric metrics, and these are good. You should use them. If you want to use them, you can do so using this thing called Lighthouse. This is built by the Google Chrome development team. Google Chrome dev, yeah. Anyway, you can install it on NPM, use it on your terminal. It's really great. But you can also now run this in Chrome. This is built into Chrome DevTools. There's a brand new tab called Audits. There was a tab called Audits before, but now it's been replaced with this. What this does is gives you an audit that gives you all of those metrics that I've talked about. It takes screenshots, it gives you accessibility information. Soon it will give you SEO information and security information. This is a really great tool, and you can go and use this right now today. Calculating time to interactive is a little bit of a difficult thing. I explained this thing called the main thread, and I didn't really say much more. It's this line here that runs along the bottom. Imagine that's a timeline. We've got these other paint metrics, first paint, visually complete, and then we've got these JavaScript tasks. And as I was saying about this parse and compile thing, we're looking for a point in time when the browser isn't doing a lot of hard work. So in this particular timeline, we're looking for a point where there aren't long tasks being executed. And so essentially, Lighthouse goes along the timeline and gets to the point where it goes, okay, everything's visually complete. Oh, there's a bit of work to do. Okay, look, here's a 5-second gap. And so if a user was to interact with the page around here, then it would react quickly. So time to interactive is a great metric. It's hard to calculate yourself. Get it in Lighthouse. And do so in less than 5 seconds on every device. Paul talked about this earlier as well. The way that you can do that is you can go and add these tools and then maybe set a budget and talk to your team about it. And if you do this, you're just creating a really great user experience. But do so on every device. So use that cheaper test phone that you have or slow your browser down. And if you can't render in 5 seconds, set that as a target and then work towards it. Or maybe you can come up with a metric that's representative of what your users are actually trying to do. Maybe it's buy a train ticket, maybe it's Twitter, whatever it is. Find a metric that works for your customers and help them get there. So if there was a checklist that I'd give you, I'd say use those metrics, test using real devices, and do it continuously. Don't try to keep people on your side as long as possible. Help them do what they want to achieve and let them move on with their lives. Performance is really, really tricky, and there's a ton of things that you can do, from using these new weird purple patterns to service workers and using SVGs and new image formats and all that sort of stuff. My advice is just try a little bit of everything. All of these things work in their own scenarios, and it depends on the content that you're building. But the best thing you can do is educate yourself to have a little play around and see how well they affect the performance of your pages. No one here set out to build the wealthy Western web. We all started to build the World Wide Web, right? Make the web fast for everyone. As I said, I work on this thing called Calibre. This is kind of what it looks like here. It runs Lighthouse. It records metrics every day or after you deploy. And I've been working on it full-time since the start of the year, and so I'm very interested in performance. So if you want to give it a shot, please do. That's all I have for you today. Thank you very much.
Thank you.